This is the Labstone video submission for Lab Group 89, and in this video submission I'll be implementing and demonstrating my socket project demonstration. The first thing I want to point out is that I am connected to the general3.asu.edu server on these two terminals here. So this is what I'm going to be using to do my bank server, or to run my bank server on, and then the other terminal I will also create a customer server on. And then on General 4 over here and General 5 over here, they will also be used to add customers. I'm doing this so that I can show that I could use 3 different customers on 3 different servers while running the bank on another separate server. Alright, so the first thing I will do is I'm going to compile my bank application and my customer application. Alright, so since those have both compiled correctly, I will now start my bank server to start listening for messages. On this, I am starting the server on the General 3 IP address at port 45,000. So now that the bank is listening to all incoming messages, I can now set up each one of these other terminals to set up a customer. First, I will have to set up the bank info at the bank's IP address and its port number. Once I do that, I can start sending commands to the bank. On this one, I will open up a customer called Rick and give him a balance of $100 and set up his IP address on the General 3 server, which is 120.70.105. The bank's port number of 45,000, and I'll give this one a port number of 45,200. So now, once that is done, it will receive a success message after it sends it to the bank. The bank has processed the customer, added the customer. As I've also implemented a testing solution where we can test that customer was added. So if we run the test command from the customer, we can see here that there was a customer named Rick added to the customer map. I've also done this so that I could demonstrate the exit method. So the exit method is just exit with the customer's name as Rick. So we get a success message, and you also see that after the bank sends a success message, the customer receives a success message, and it closes the entire process. So now if we want to verify that Rick was moved or deleted, we just open it up again and we can do the same test command. You can now see that there are no customers inside of the customer data structure in the bank. Okay, so now that that is demonstrated, we can demonstrate the rest of the functionality. So we'll restart the bank service, and I can add, I'm going to add Rick back. So it's going to be open Rick, give him the same balance, the same IP address. Yeah, 105.45. Okay, so now we have Rick. Okay, so now we can start implementing on different servers. So now go here, we'll open up a customer called Tom, give him a balance of, we'll say this time 200, put him on the General 4 server, which is 120.70.146. Give the port number for the bank, which is 45,000, and we'll give him the same port number since he's on a different IP. See that he is now added. And now do one for the Journal 5 server. We'll open Hank, give him balance 250.50 at IP address for the Journal 5, which is 10.120.70.113. At port number 45,000 for the bank and 45,200 for him. Alright, so now we have all 3 customers added. We can now verify that we have all customers by just doing the test command, and you can see here in the bank that we do have Tom, Hank, and Rick. For my data structure, these are the keys, but their names are also included in the hash map inside of the hash map. So you see that the name is Tom, Hank, and Rick. I've done this so that I can pass this along as an array list later on, or an array list of hash maps, I would say, so that I can easily access this on the customer side and send it through peers. So now that we have all these cohorts added, or all these customers added, we can start implementing my cohort design. For my cohort design, I have made a function called listen. Let me just verify. No, it should be listen for cohort. So I would need to run this on 2 of my customers, and basically what this is doing is just listening to see if they are being added to a cohort. The issuing customer will need to send the cohort command, so the new cohort command will be sent from Hank, and we want to do a cohort of 3. So now you can see that the bank sends a message over here to Hank saying that there was a cohort added of 3, and each one of these customers now have that added to their local variable I've signed here of array list of hash maps. So you can see here the public static array list of cohorts are in there. I've also added a command for each customer so that you could check this. So you can also see here on both of these, they were listening, they received the cohort information from Hank, and now you can enter a command. So the command we're going to enter is called print cohort. From here you can see the cohort that was assigned, which is Hank, Tom, and Rick. So now you can we can do the same thing for here, so that you can see that each of these guys were added to the same cohort. So Hank, Tom, Rick, and you can see the same Hank, Tom, and Rick. So now we can do pretty much the same thing, but this time we'll listen on these guys. So to delete a cohort, I've implemented a listen command, so that now we'll need to change this at some point. It's not null, it's just I didn't assign that value for the name functionality yet. So if I listen, now it's just listening. Each one of these customers are just listening for the delete command, which I'll issue over here from, I forgot what this guy's name is. So this is Rick. So we could write delete cohort Rick, and we get the success message. Obviously that doesn't mean much until we show that there is no longer a cohort assigned. So now you see print cohort, and there's nothing because the cohort was deleted. You could also verify over here with the other customers. So yeah, so I think this Tom, his was deleted, and then we'll test it for Hank. So yeah, you can see his cohort was also deleted. So yeah, that is my functionality. I think that was all that was required to be shown. I guess we could also just exit out of these. So exit to delete the customer information from the bank. So exit Rick. So Rick is successfully exited. He cleared his information and he is now exited from here. So now we'll exit for Tom. And then also exit for Hank. I also added some other functionality to close the bank from a customer. So now when the close bank command is issued, the bank is closed, and we can just exit from here. And that is my implementation for the Socket project for Lab Group 8.9.